Assalamu alaikum. Bismillahir Rahmanir Rahim. In the name of Allah, the most beneficent and the most merciful. Guys, today I'm going to explain you about the logarithmic function, right? Logarithmic function. What is a logarithmic function and how to solve the questions of domain, how to find the domain of logarithmic functions. I will give you some complicated question and it is not easy to solve, right, without knowing the concept of logarithmic functions. So I'm going to tell you the concept of logarithmic function, how it has been developed from the exponential function, and how to draw the graphs. Okay, the important things that you must know about the graph of logarithmic function with different bases, right? So once you understand the core concept of logarithmic function, especially in the terms of graph, then it is so easy to solve the question of domain. Okay, so here I will try my best to give you the best explanation of logarithmic function, right? I'm not going to tell you in deep. I want to tell you something about the graphs so that you can solve the question of domain, right? Okay, so the question here, please try to understand the question here. For example, if you have log, right, log log x, and here is your base here, a. Okay, a is the number. It may be a is the positive number. A is the positive number. A is greater than 0 and a is not equal to 1. Okay, I will tell you the cases here. Means note this a is greater than 0 and a is not equal to 1. This is very important. This a is greater than 0. Greater than 0 means positive numbers, right? And a is not equal to 1. It means you are not going to write 1 here. It may be 1.2, 1.3, 1.4, 2, 3, 5, 0.5, 0.6, but not negative. And a is not equal to 1 means you have to see just two conditions here, right? And now your function is y is equal to log ax. Okay, maybe I can give you some example. Maybe you can see here log 2x. Maybe you can see log 0.5x. Maybe you can see log 1 by 10x. Okay, maybe you can say log 10x. Maybe you can say ln e. Maybe you can say log base ex. These are the examples that I can show you here, right? This is log 2x where a is 2 and this is positive, right? Log 0.5x, which is also what? The base is 0.5, the positive number. 1 by 10, okay? 1 by 10 means 0.1, which is greater than 0. Here the base is 10. Here I have written ln. Look, if I just write down this one, if you have a log and the base is e, okay? If you have a log, base is e. For example, here I'm going to mention, if you have a log, right? Okay, if no base is here, for example, if no base is given, right, you must understand that 10, right? The base is 10, number one. So log 10, right? So log 10 x, okay? So if sometimes you will see it is written log x, no base is here. So you must know the base must be 10. This is the first point that you must understand, okay? And as I told you, e is a irrational number, right? E is a irrational number, is an rational number. Rational number, and the value of the e is greater than 2, less than 3. You know about it, 2.71 something, okay, 2.71. So if ln x is given, it means the base is e, right? it means the base is e. If ln is given, right? We have two log, common log and the natural log, right? So natural log, so we can say, or if log is given and I'm going to write down e x, so you can say log ex or ln ex, both are the same things, right? Okay, now I want to tell you about the graph. I'm not going to explain you right now how it has been developed, how it has been derived from the exponential function, right? Because log is nothing, they are the inverse of exponential function. But here we have to explain about the domain, so I will focus about those points, which is very, very, very important when you are going to solve the question of domain, right? Okay, now draw a graph of logarithmic function. Logarithmic function, this is very important because I will solve all the questions, even the question is so complicated, right? If I know that this concept that I'm going to explain right now, okay? So this is very important, please try to understand, right? If I give you, here I'm going to explain you, my question is, this is the syntax, right? Log ax, okay? If this is given, if the log is given in the question, right? Okay, so here I just make two cases. Case 1, this is case 1. Case 1 means when the a, this value a is greater than 1, okay? Greater than 1, I am not saying that is equal to 1, right? A is greater than 1, right? Like 1.1, 1.2, 1.3, 1.4, okay? So if a is greater than 1 here, so the graph is always, the graph you will see, the graph is always like this one. This one, always, okay? And here in this graph, you must know two important information. And with these two important informations, you will solve the question easily, right? This is very important, okay? So first of all, how you will make the graph of this one, okay? It will come from the down, it will intersect here, and then it will go on the right side, right? If the value of a is greater than 1. What are the two important points? The first point, which is very important, which is here, this x-intercept, this one. This point, I can say this point is a, right? This a point is very important, and the order pair here is always 1, 0. It's always 1, 0. Even the value of a, if the value of a is greater than 1, you will find one intercept, and the coordinates or the order pair would be always 1, 0. It means x is 1, then y is 0. Understand the first point? The x will be 1, y will be 0. So if you have log 2x, log 3x, log 4x, log 5x, log 6, log 7x, the first order pair will be what? Log 1, 0. I can give you one example. For example here, if I say log 2x, right? So log 2x can be written as log x divided by log 2. And when x is equal to 1, log 1, okay? And this is log 2, okay? So you can say log 1 will be 0. So this value will be 0 always, okay? So whenever you have x1, y will be always 0. This is very, very, very important, right? So x1, 0. This is the first point that I told you, this first point A. And the second point here you will get, the second point here. The second point, right? This is also very important. The point B. What is the order pair of this one? When this x, this one x, if this x become a, this one, when x becomes a, for example, this is the graph of log 2x, for example, right? If this is the graph of log 2x, okay, so thus the first order pair I told you here 1 comma 0, put if x is 1, if x is 1, whatever the base is, if x is 1, the y coordinate must be 0. This is the first point, right? And the second point, when this x become a, it means when x is equal to 2. When x is equal to 2, it means you can say log base 2 and this 2. It means this can be written as log 2 divided by log 2, which is cancels 1. So it means when x become a, means we can say here when x is equal to what? 2, right? Then the order pair, the value of the y is always 1. So the pair is 2 comma 1. So y coordinate must be 1. This is very important, sir. Okay, so if x become a, at that time the y coordinate must be 1. If you have these 2 points, you can solve all the question, even the question is so complicated. Okay, you will not find this strategy in any book. Okay, you have to use your own mind. Okay, so if these 2 points are clear, then you can solve all the question. Okay, now we will discuss about the domain and the range of this one, right? Okay, and then I will tell you some inequality. So first, domain. So I'm going to erase this part and explain again. See, in this case, when y is equal to log ax, where a is greater than 1, so the graph is always this one. Right? So the first point A and this point B. This is always A and B. There must be only one x-intercept, right? So here the coordinate here, as I told you here, if x is 1, right? So the y must be 0. This is the first point. And the second here, if x become a, means we can say if x is a, at that time y become 1. Is this is x is equal to what? A, and this is y, which is what? 1. So you can say a comma 1, okay, and then so on, right? These 2 points. So here I'm going to explain you the domain. Domain of log ax. Okay, so the domain here, so x always greater than 0. A very important point, right? X must be greater than 0. Means here, if you have this log and the base is a x, then this x is greater than 0. This is not equal to 0, is greater than 0. This is the domain. We solve the question of domain. We solve the question of logarithmic function. Okay, so we must know about these things. This must be always in your mind, that the value of x is always greater than 0, and the range, okay, the range is always from minus infinity to positive infinity. You can say the range is real number, right? From minus infinity to positive infinity. Okay, so the range you can get the minus infinity to positive infinity, it doesn't matter, right? But the domain means we have to discuss, we are discussing about domain, so this x must be what? Greater than 0. Okay, this is very important. And here also we can say some inequalities that are very important, very important. Okay, so here I'm going to mention, if the value of x, if not here, okay, I explain you everything here, right? So if the value of x, if the value of x is greater than 0, if the value of x is greater than 0 but less than 1, see here, if the value of x is greater than 0 but less than 1, at that time the nature of fx, is always less than 0. This is very important. If the value of x is greater than 0 but less than 1, the inequality, the function always less than 0, it means the function has negative value, right? And even I want to tell you, if the value of x is very close to 0, then the function has minus infinity values, right? So fx is always less than 0. So in this case, the log with base ax is always less than 0. The second point, point number 2, when you can say when the x is greater than 1 but less than a, this a is your number, right? And a is your base here, right? So when this one xa, this is very important, the second inequality. If the value of x is greater than 1 and less than a, at that time our function will be greater than 0 but less than what? 1. Means if the value of x is greater than 1 and less than a is your base, okay, so whatever at that time the function has greater than 0 positive value but less than 1, means this portion only, you can say this one. Okay, and the third inequality, this was the first one, is the second one, and this is the third one. If the value of x, means if the value of x is greater than a, okay, if the value of x is greater than a, at that time the function, this is if x is greater than a, then at that time the function fx is always greater than 1, always greater than 1, maybe 1.1, 1.2, 2, 3, 5, 6, 8. So if the value of a is greater than 1. So these are some inequalities that will give us the information when we will solve the question of domain, right? So these are the things in case 1 that I told you now. Now we will discuss about the case 2. Case 2 means when the value of the a, value of the base, is greater than 0 but less than 1. So we will see this one. Okay, so we discuss about a case number 2 here. Case number 2. Case number 2, that if you have y log ax where this a is greater than 0 but less than 1. If the value of a is greater than 0 but less than 1, then the graph Okay, this will be always from this side, always. Okay, like 0.1, 0.01, 0.2, 0.3, 0.4, 0.5 is greater than 0 but less than 1. The graph of this one is this one. Okay, and this case also has two important points. Okay, so this is very important. The first point is the same here, as I told you, this one. Okay, so this is 1, for example. So whenever x is 1 in case 1 or case 2, y is always 0. The point is, for example, here a, right? So the first point is the same in both cases. Remember this thing in your mind, right? So if the value of a is greater than 0 but less than 1, at that time the x coordinate must be 1, 0, right? At this point a, the order pair of a at a point is 1, 0, right? Okay, now as I told you, this is your 0, right? This is your 0. So I am saying that when a is greater than 0 to less than 1, I'm talking about this one. A is 0 means greater than 0 and less than 1. So if you are here, for example, if you are here, I'm saying, for example, this is my a is this one here, right? So when the second case, when x become what? When x become a, at that time the value of the y must be 1. So you can see here, if this a, so you can say I got this point b, so it when x become what? A, okay, and here a is between 0 to 1, right? So y is always 1. So you can say this value is 1. So I got the graph of log ax where the value of a is between 0 to 1, right? So this is point A and this is point B, right? Okay, so now I'm going to tell you the concept of domain and range and some inequalities, right? So again, in this case also, the domain here is also what? Greater than 0, means x is greater than 0. So value of x must be greater than 0, okay? And range does not have any problem because it has positive value and the negative value. So you can say from minus infinity to positive infinity. Doesn't matter. Okay? Or you can say positive infinity to minus infinity. Doesn't matter, right? Positive infinity to negative infinity or negative infinity to positive infinity. This is called what? The range. Now inequality, this is very important. Please have a look on this, because if you don't understand this concept, you cannot solve the complicated questions related to domain. Okay, so please see this one. So I'm going to write down here. So if note, I'm going to tell you 3 points, right? First point, if x okay is less than 1, or you can say if x is between 0 to 1, right? Between 0 to 1. So if x is what? Greater than 0 but less than 1, for example, I'm talking about the x, I'm not talking about the a, I'm talking about the domain. If the x is greater than 0 but less than 1, like here I can give you 0. Means log a 0.1, log a 0.2, 0.3, something like this. Okay, at that time fx is the greater than 0. This fx, when the value of x is 0 to 1, and fx is the positive values, right? It has the positive values, right? It has the positive values. Number 1. Okay, it's the positive values. So when fx has the positive value, when x is greater than 0 but less than 1. And the second point, when I say if x is greater than 1, if x is greater than 1, here you can see, if x is greater than 1, at that time the function has negative value, right? Then we can say the function is less than 0, means it has the negative values. So when x is greater than 1, fx has less than 0. In this case, positive value, when the value of x is greater than 0 but less than 1, and here fx is less than 0 when x is greater than 1, right? Okay, so these are the two important inequality, and I'm going to tell you the third point. The third is very important. If I say if the value of x, if the value of x is greater than a but less than 1, see here, if the value of the x is greater than a but less than 1, at that time the function has greater than 0 but less than 1. At that time this function has what? Greater than 0 but less than 1, right? Okay, and the fourth inequality, the fourth point I'm going to tell you, this is also very important, right? The fourth point is if the value of x, see here, if the value of x is greater than 0 but less than a, if x is what? Greater than, here, greater than 0 but less than a, okay, here, greater than 0 but less than a, at that time the function is always greater than 1. The function always greater than 1 means the value of fx must be greater than 1, maybe 2, maybe 3, maybe 4, maybe 5. So guys, these are the important points of logarithmic functions, right? As I told you in before that logarithmic functions are just the inverse of inverse of exponential function, but here this is not the correct time to explain you that. Here we have to solve the question of logarithmic functions, right? Especially in finding the domain, and you will see the question is so difficult, so question is so hard. But if you know just this concept only, case 1 and case 2, and some inequalities, the domain, then the question would be so easy. Now I'm going to upload at least 5 to 10 videos based on that. Inshallah, you will not face any problem, guys. I hope you understand, and please watch my next video that is related to logarithmic functions, and there I'm going to find out the domain using the same core concept of logarithmic functions. Take care, bye bye, assalamu alaikum.